When a disaster like a massive flood strikes, our eye in the sky is one of our most important tools. Satellites give us this incredible view from above, but getting a clear, accurate map of the damage and getting it fast is a huge challenge, and it's one where every single second counts.
Okay, so let's get into it. We've got these amazing satellites circling the globe, grabbing just terabytes of data. And the goal, right, is to turn that raw imagery into a simple map that shows first responders exactly where the water is and where it isn't. But the real bottleneck in this whole life-saving process, it isn't the satellites. It's something else entirely.
It's the AI we use to actually make sense of those images. For a while now, we've been building bigger and bigger AI models, just assuming that bigger has to be better. But what if, for this very specific, incredibly critical task, our most powerful AIs are actually getting it wrong?
And this is where we hit a real puzzle. Researchers found something that just feels totally backwards. So on one side, you have these massive geo-foundation models. I'm talking hundreds of millions of parameters, the real heavyweights. And on the other side, you have a much smaller, kind of older model called a UNet. And in test after test for mapping floods, the little guy consistently won. So that raised a huge question. Why were our biggest, most powerful AI brains failing at this?
Well, the answer really comes down to how these different AIs are designed to see the world. It's basically a conflict between seeing the big picture and seeing the super fine details.
So, those massive models, they're built on something called a transformer architecture. The best way to think about a transformer is like a general looking at a giant battle map. It is brilliant at understanding the overall situation, seeing how one part of a flood connects to another part miles away. It gets the large-scale context. It sees the forest. The smaller UNet model, though, is a convolutional neural network, or a CNN. And a CNN is totally different. It's more like a scout on the ground. It's a detail specialist, and it is exceptionally good at recognizing tiny, local patterns, like the exact jagged edge where floodwater meets dry land. It sees the individual trees.
Okay, so here's the problem in a nutshell. The big transformer models could see the flood, no problem. They understood its overall shape, but they were super fuzzy on the details. They just couldn't trace the boundary accurately, which, let's be honest, is the most important piece of information you need. The general saw the whole battle, sure, but it was the scout who knew exactly where the front line was.
So, what do? Well, you don't choose between the general and the scout. You get them to work together. And that exact thinking led to a brand new hybrid model called Prithvi CAFE.
Now, I know this looks really complex, but the idea behind it is actually beautiful and simple. Prithvi CAFE doesn't make you choose. It takes the big picture brain of the transformer and the detail specialist brain of the CNN and basically has them look at the exact same satellite image at the exact same time, working together.
Here's how it pulls it off in 3 pretty clever steps. First, it intelligently splits up the satellite data. The parts of the image that are best for overall context, they go to the transformer brain. The parts that are packed with fine details, they go to the CNN brain. Second, both brains get to work on the image at the same time. And third, and this is the magic trick, a smart fusion module merges their 2 different views. This creates one single, unified map that has both the big picture context and pixel-perfect detail.
Okay, so the theory sounds great, but does it actually work in the real world? It was time to put this thing to the test, a real head-to-head showdown to see if this hybrid approach really was all that was cracked up to be.
And oh, did it work! Here's the proof in one single powerful number. When they tested it on a brand new flood site in Bolivia, one that none of the models had ever seen before, Prithvi CAFE didn't just beat the old UNet model, it absolutely crushed it with a performance leap of nearly 11 points. That is a massive deal, and it shows this thing can generalize to new disasters, which is exactly what you need.
And this chart, wow, this really puts that number into perspective. You can see the baseline UNet chugging along at around 70. The original, huge Prithvi transformer model, only a tiny bit better. But then look at Prithvi CAFE. It's a massive jump, all the way up to over 81. This isn't just a little improvement, it's a fundamental leap in performance. It proves the whole hybrid idea just works.
But let's see what that actually looks like, because numbers are one thing, but pictures. So on the left, you've got the ground truth. That's the real flood map. That's our goal. Now, look at the UNet's map on the right. It gets the general shape, kinda, but you can see it really struggles with those smaller, intricate waterways. It just misses so many of the fine details, leaving you with a kind of blurry, incomplete picture.
Okay, now let's check out the original Big Prithvi model, the big picture thinker. It does a decent job on the main body of water. That's its strength. But again, look at it next to the ground truth. It completely misses all those thin, branching streams. It's almost like it can't even see those small details, which leaves these huge, empty gaps in the map where there's clearly water.
And now, look at the map from Prithvi CAFE. The difference is just stunning, isn't it? It nails the main body of the flood and all those delicate branching details. The whole map is just visibly sharper, cleaner, and so much closer to the ground truth. It sees the big picture and the fine details. This is the kind of accurate, reliable map you want to send to a rescue team.
So, you can see this isn't just some cool academic exercise or a fun science project. A breakthrough like this in AI, it has profound real-world consequences. Bottom line, better maps lead to a safer world. So what does that actually mean for people on the ground? Well, it means getting faster, way more precise maps to first responders so they know exactly which roads are cut off. It means cities can better plan for future flood risks. It helps us track the real impacts of climate change with so much more accuracy. It means getting aid and resources to the right places way faster. And ultimately, all of that together means this technology is about saving lives and protecting property when minutes matter most.
This whole story really comes down to teaching an AI a pretty simple but profound lesson. You need to see both the big picture and the tiny details, the forest and the trees. And it really makes you wonder, if this approach can so dramatically improve something as complicated as mapping floods, what other huge global challenges could we solve by teaching our AIs to see the world in this exact same way?